Hi, friends and my dear friends. Today we are going to see the laws of photoelectric effect in physics 12th physics in second volume. This is very important for the examination purpose. Try to go through the concept deeply, then you will get sure 5 marks in your annual examination. Now, as per already we studied about the electro electric photoelectric effect by means of theoretically and experimentally we got more results regarding photoelectric effect. On the basis of that theory as well as experimental data, we conclude that very important laws as follows, as I already wrote in the blackboard. Whiteboard, sorry, whiteboard. The first law of photoelectric effect. Listen carefully, that's why I give more importance for this question. The laws of photoelectric effect, the first law of photoelectric effect. For given frequency, for given frequency, or you can say nu, for given frequency of instant light, for given frequency of instant light, the number of photoelectrons emitted, that means for given frequency of instant light rays, then the number of electrons that are produced is directly proportional to the intensity of the instant light. That is the law. Once again I repeat, for a given frequency of instant light, the number of electrons emitted is directly proportional to the intensity of the instant light. That means the number of electrons are directly proportional to the intensity of the instant light. That's all. This is the first law. For your convenience, you have to note like this very simple manner. From this, you can write or develop this laws as in the form of in the textbook itself. Right. Once again, I repeat. For a given frequency, known frequency, for given frequency of instant light, the number of electrons emitted is directly proportional to intensity of the instant rays. That is the first law. I hope you may understood. Then in the second part of the first law, this is the first part. Second part of the first law, the saturation current is also directly proportional to the direct. Here it is called directly proportional. For simplification, that I have to put the signal. This is called directly proportional. Okay. The saturation current is also directly proportional to the intensity of instant light. The saturation current are directly proportional to intensity of instant light rays. These two combined and called as a first law of photoelectric effect. Very important. Once again I repeat, the for a given frequency of instant light rays, then the number of electrons emitted by the process are directly proportional to the intensity of the incident light rays. That's the first part of the first law. And second part, and the saturation current of this process is also directly proportional to intensity of the incident light rays. This is the first law of photoelectric effect. I hope you may understand clearly the second law of photoelectric effect. What is my second law of photoelectric effect? Maximum kinetic energy of photoelectrons. Maximum kinetic energy means kinetic energy maximum. Kinetic energy maximum of on electrons. Maximum kinetic energy of photoelectrons from a given metal is directly proportional to frequency. This is called frequency. Directly proportional to frequency of incident light. Are you clear? So the maximum kinetic energy of on photoelectrons, maximum kinetic energy of photoelectrons are directly proportional to the frequency of the incident light. This is the second law. Very simple, but you understand the concept like by the hints itself you can write. The kinetic energy, maximum kinetic energy of an electrons are directly proportional to the frequency of the incident light rays. The frequency of the incident light rays. That is the second law. Then third law, minimum kinetic, the maximum, here it is called maximum. Maximum kinetic energy of photoelectron is independent of intensity. Independent of intensity means it does not depend on intensity. That means the kinetic energy, the maximum kinetic energy of photoelectrons is not depend on or it is independent of intensity of incident light rays. Intensity of incident light rays, very important. Once again I repeat, the maximum kinetic energy of photoelectrons is not dependent on intensity of incident rays. In other words, you can write like this: the maximum kinetic energy of electrons are independent of intensity of the incident light rays. That is very important. Very important. The fourth law of photoelectric effect. Fourth law of electro effect. For a given surface, whatever it may be the metal, for a given surface, the emission of photoelectrons take place only if the frequency of incident light is greater than certain minimum frequency called threshold frequency. What is the meaning of this law? If you consider any surface, whatever it may be, or surface of any metal, the electron emission may happen only if the incident ray whenever hit the surface of the metal, there may be ejection of photoelectrons. Here, the photoelectrons are be ejected only if the frequency is greater than the threshold frequency. That's all. This is a very simplest form of explanation. Can you understand clearly? For a given surface, the emission of photoelectron take place only if the frequency of the incident light rays is greater than the minimum frequency called threshold frequency. Then only the electrons are emitted. That is the fourth law and very important concept. This is the key to analyze, understand the. This is a very smallest key to understand the concept. Easy manner. You can write in your notebook or you can write in textbook itself. Then once again repeat the fourth. For given surface, the emission of photoelectrons take place if the incident frequency or the frequency of incident rays or the frequency of incident light is greater than the minimum frequency called threshold frequency. That's all. Minimum frequency, this is called threshold frequency. This is a very important concept. And finally, there is a there is a time lag between time lag between there is a time time there is a time lag between instant light and ejection of photon. What is the meaning of this sentence? If suppose you consider any metal or any surface of metal, the instant ray which will hit the surface, then it will take some times, then eject the electrons. So this lag means it will take some times, is less than, the lag is less than 10 power minus 9 second. This is a law. Very important to understand to analyze this fifth law of photoelectric effect. Very, very important. Once again, I repeat, you understand the concept clearly. There is a time lag between instant light and ejection of photoelectrons. Time lag between instant light and ejection of photoelectrons should be less than 10 power minus 9 second. That is, this process is called instantaneous process. That means whenever the instant light rays which will hit the surface within the 10 power minus seconds, the ejection of the electrons may happen. There is no lag. There is no lag. That's a very important concept. In other words, in very simplified manner, there is no time gap. It is instantaneous process. Whenever the instant electrons hit the surface of the metal, then instantaneously the photoelectrons are ejected. That's a very important concept to analyze this laws of photoelectric effect. I hope with the help of these hints you may understand clearly about this concept clearly, and you can eligible to write 5 marks at present now. Are you happy? Thank you. Once again I meet you in the next 5 very important 5 marks. Thank you all. Subscribe to my channel and click the bell. Thank you. Thank you.